Welcome to the Stormsurf video surf forecast for the week starting Monday, January 23rd. Looking at significant wave heights for the North Pacific Ocean, we see an obvious storm developing on the dateline with 46-foot seas aimed to the east. Also relative to California, a previous storm system which had seas up to nearly 40 feet is continuing to stir, regenerating somewhat, producing 24, 28-foot seas, pushing towards the California coast, providing yet another 2 days at least worth of a rather raw sea state. Let's dig into the details. As usual, start looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when those gales do form, the jet stream helps direct their track. We're looking for a trough, a dip in the jet, just like right here, being fed by, well, look at that. It's a very strong flow pushing off Japan, winds to 200 knots, and they're falling into that trough. That helps create a counterclockwise flow aloft and down at the surface, and of course, that's the hallmark of low pressure. Low pressure generates winds, winds generate seas, seas produce swell as they radiate away from the fetch area, and ultimately result in surf at your beach. So, we got a great looking jet stream flow in place right now over the West Pacific, across the dateline, into the Gulf of Alaska. But notice there, the jet stream splits a little bit. Some of it running to the north, some of it running to the south, but then it reconsolidates just off the U.S. West Coast. We have another trough, sort of a backdoor trough, bringing in cooler air, but also helping to create a counterclockwise flow there at the surface, and that is also helping to generate seas in this area. Low pressure, of course, and some weather still in the mountains and down into Southern California. Moving in time, we see the Gulf trough moving Tuesday deeper into the Gulf. Winds continue at 200 knots over the dateline, but the trough kind of starts falling apart by Tuesday. The other trough along California is inland and fading fast. And then we move into Wednesday and Thursday. Notice the jet just holding rock solid from Japan the whole way over the dateline into the Gulf of Alaska. The split portion of the jet pretty much holds its position, maybe easing just a little bit to the northeast of Hawaii, but no clearly defined troughs immediately until you get here into nearly Friday. And then we see another trough developing in the, we'll call it the northwestern Gulf of Alaska, continuing on into Saturday. But notice winds definitely dropping off here in the jet. It was 200 knots. Now here, I'll just pull away. You can see it's down to about 170, 180 knots. The split, very well pronounced. Cutoff low down here somewhere well southeast of Hawaii. Big ridge, just, this supports high pressure, basically. And winds off Japan starting to drop off as well. This won't help build this trough too much stronger or low pressure in it. Then we get into Sunday and things get even weaker. But notice now winds start picking up in the jet off Japan, but the split point, you can see it, just a split starting to develop there on Sunday. Just a little bit off Japan. We'll just roll this out further. There we go. You see the same sort of thing going on. We'll take it right on out to 180 hours. There we go. And you see good winds, a trough here developing over Kamchatka, but then you have this big split over the dateline, another bit of a trough trying to dig out in the Gulf, but notice there's not a lot of wind energy pushing into it. Whatever wind there is off on the southeast quadrant of the trough, so that would really support winds pushing up this way in the low pressure. And what we really want is the energy to be in this portion of the trough. We'll call it the southwest quadrant. That's what drives energy towards California, or if the trough were back here, more at Hawaii. So a less energetic pattern looks to be taking shape. We'll call it 5 to 6 days out, and that likely has something to do with the MJO. We'll get into that in a minute. Now we're looking at surface level pressure, surface level winds. Clearly we see our storm in the Gulf, western Gulf of Alaska dateline area, 50-knot winds, 18Z Monday. Another low trying to organize off Japan, also supported by that very strong jet stream flow aloft. And then remember we had that backdoor trough off of California. Sure enough, there's another low, 35, almost a little tiny quadrant or a little pixel of 40-knot northwest winds generating seas off the California coast. We'll just sort of roll this out. You can see as we get into Tuesday, the low off California starts falling south, moves to about Point conception and dissipates. The low or the storm that was in the Gulf of Alaska fades rapidly, and the new system that was off Japan sort of trying to hold together, but not very impressive. We'll just sort of roll this out some more, see what happens. Low pressure, here we go, over the date line come Wednesday night. Small fetch of 35 knot winds aimed at Hawaii. But these winds here, sort of this is what they call a complex low or complex gale. Multiple centers of circulation, all sort of rotating around, not particularly well organized in one cohesive whole, but just the same. Here we go, 40 knot winds by Thursday, again aimed at Hawaii and sort of at the U.S. West Coast. Continued swell, and that moves into the Gulf of Alaska on Thursday night. Into Friday, 45 knot winds, again north of Hawaii. Notice bits and pieces of energy all over the place. Another secondary gale forms on the dateline on Friday night. 40 knot winds building to almost 45 knots, falling southeast towards Hawaii. The focus will be Hawaii on this one, at least immediately. Looks like some good potential for swell energy, but also look at this, a lot of wind moving right into the Hawaiian Islands on Sunday. And then this system starts taking off to the north, still with northeast fetch aimed back at Hawaii. Also a new system building off Kamchatka, but most of this energy looks like it's aimed towards the Bering Sea. Very little at Hawaii. Then we get 180 hours out. Big stretch for the models, but this system, this sort of pattern dipping towards Hawaii. Now we were at storm status, 50 knot winds. Also, kind of a rare angle for very north angled for Hawaii. A lot of wind over the area there, but solid storm. The thought or hope is at some point these winds start wrapping around more into the south quadrant. Remember, in low pressure, winds circulate counterclockwise around low pressure in the northern hemisphere. And that would ultimately, if it happens, start producing solid fetch aimed at the U.S. West Coast. So in short, a pretty active pattern is looking to be setting up. Let's take a look at the wave models. So here we go. Significant wave heights for the North Pacific Ocean, as we talked about before. Fetch and seas off the U.S. West Coast, but our big focus is the system on the date line. So we'll just take one step forward. Now this is interesting. The previous run of the model, the 06Z, had seas building to almost 50 feet as of 18Z. Now the latest run of the model shows something significantly less, only, 46-foot seas at 18Z, okay? And also notice they're just north of the 45 north line. This suggests shadowing relative to the San Francisco Bay Area. You really want to get south of that 45 line, and there's an arc along here. You can figure it out looking at the Great Circle charts. But bit of a shadowing maybe just for this area here. Anyway, so, one other thing. Let's take a look. So we did get a good JSON-2 satellite pass over a portion of the storm. So this little track here, that's the satellite as it JSON-2 satellite as it orbits around the poles, North Pole to South Pole, and it happened just by luck to make a pass over at least a good portion of the storm. Peak seas right there, 48 feet. That's what the model suggests based on, so wind models generate attraction on, wind models generates wind speeds. Wind speeds are then fed into the wave model. The wave model then calculates the effect on the ocean surface. It calculates 46-foot, 47-foot seas here, and what is this, 40, 41, 40, 42 to 43-foot seas under this satellite pass. So we are able to analyze this data automatically. The max average measurement was 40-foot seas at 45,173, which is roughly right about there. Okay, it's a 15 reading average across there, and the absolute maximum reading over that area was 44 feet at 46.7, so roughly right about there. So it says seas under here are basically 40 to 44 feet, and the model says 42 to 43 feet. So basically the model's spot on, doing a good job of imaging what's happening in this storm well out at sea. So then, back to the wave model, roll this out. You see our storm making it into the Gulf on Tuesday, quickly, rapidly fading apart and getting weaker, while the system off the California coast also fades. New system developing, approaching the dateline on Tuesday, 30-foot seas, but it sort of falls apart. Can't quite get it together because the jet stream, though it has strong winds, there's no trough to really help do a lot of feeding of the system. Now we get into even Wednesday night, still 26, 27-foot seas here, pushing towards Hawaii, certainly swell to result. And then we got into, where are we, on Thursday, 30-foot seas, and that fades out. Another system developed. This is probably the stronger one, more significant. Now notice this fetch here, also aimed at the U.S. West Coast. Swell for the weekend seems highly likely, though period, with 26-foot seas, you're talking maybe 15-second period. Anyway, okay, we move into Friday evening. New system developing on the dateline. Seas building 32 feet, aimed directly. You can just watch them falling at Hawaii. That's a good news. Large swell for the islands, but moving very close. We have 20-foot plus seas within a couple hundred miles of Hawaii. Sort of seems like Hawaii is going to end up for the coming weekend the way California did last weekend. And then this system, of course, starts lifting north, regenerating, and we're looking to see some energy pushing towards California, but certainly a lot of energy impacting and still being generated relative to Hawaii. An active pattern is in play. Let's look longer term. We'll talk about the MJO and La Nina. Well, maybe not La Nina anymore. So our first order of business in the long-term forecast is try to understand what's going on with the MJO. So there are multiple cycles that run across our planet at any instant in time. The shortest term cycle, of course, is night and day cycles that affects temperature, but not so much things that we're interested in. The MJO, Madden-Julian Oscillation, runs about 3 weeks on, 3 weeks off across the Pacific. Beyond that, there's the seasonal cycle. Every year, of course, seasons change. That is a cycle. And then the longer-term cycle beyond all that, the Pacific Decadal Oscillation, anywhere from 15 to 25 years on and 15 to 25 years off. So in that context, we're looking at the Madden-Julian Oscillation, looking for some signs of the active phase. The active phase of the MJO feeds the jet stream during winter months, helps to create storms in the Gulf of Alaska across the dateline region, very much like what we're seeing right now. Strong winds pushing off Japan. That's all classic, what appears to be active MJO symptoms. Now, what we really look for is down here. Well, we'll put it right here. So here's New Guinea. Ecuador is over here. This is the equator. The Kelvin wave generation area from 170 west, just east of the dateline here, over to almost the Philippines, 5 degrees north and south of the equator. You look for slackening winds like what you'd think is happening right about here. Notice we have easterly trades over most of the equator. All this is from the TAO buoy array, series of buoys strung across the equator. But for differences in normal for this time of year, it's normal to have strong easterly trades here. And you look at this portion of the graph and says, yeah, things are pretty much normal. We're just looking at the little arrows. Now notice these are strong arrows here in the Kelvin wave generation area, but that's also normal. Basically, we have neutral winds in the Kelvin wave generation area. So that doesn't either support the thesis that the active phase of the MJO is in effect or the inactive phase. And you know what? That's been kind of the case all winter because La Nina is in play. And for whatever reason, La Nina has sort of taken the energy out of the MJO, and the MJO just doesn't show itself well at all. Doesn't seem to be feeding or stomping on the jet stream. It's just sort of there but weak. But continuing on that thread, we look for wind. What's the forecast for winds in the Kelvin wave generation here? So this chart here is wind anomalies, 850 millibar winds. So that's up about 4,400 feet across the entire planet on one chart here, and over time down here. Kelvin wave generation area, again, roughly the dateline to the Philippines is right between these two tick marks going down on the chart, going from December up towards current time here. We see we had a little bout of westerly winds here in Earlier in January, westerly anomalies. We also had strong easterly anomalies, and it was almost splitting the Kelvin wave generation area in half. At the end, we decided it was a Kelvin wave that was causing these easterly winds and not really anything to do with the MJO. The current forecast, January 23rd, has the blues are easterly anomalies over the Kelvin wave generation area. If anything, that suggests the inactive phase of the MJO. And looking for the next week, that pretty much holds just a little tiny fragment of westerly anomalies. So not much sign here of the active phase of the MJO, which means not much sign of support for the jet stream or storm development. But we know that what's going on in these charts is not active, or is not necessarily a good representation this winter of what's happening with the jet stream. So we continue to look for signs of the active phase of the MJO. We start looking at outgoing long-wave radiation charts. The oranges and reds suggest clear skies, no clouds, high pressure, which actually is a sign of the inactive phase of the MJO, right there over New Guinea. Would sort of make sense with easterly anomalies in that area. And for the next week, this, per the statistical model, the active phase or the inactive phase of the MJO is to basically hold for 2 weeks while the active phase stays bottled up in the Indian Ocean. Likewise, the GFS ensemble model suggests much the same thing. I don't know how the inactive phase is just going to dissipate, between 5 and 10 days out, and then all of a sudden the active phase is going to start working its way into the West Pacific. But there's a bit of a discrepancy between these two models. They're not quite sure, but right now I think it's pretty safe to say that the inactive phase of the MJO is trying to get its toe into the door in the West Pacific. If that were the case, and remember we looked at the jet stream charts, they showed the jet stream splitting about a week out, that would all sort of sync up, suggesting that the active pattern that we're in right now is probably going to not get much help and is probably going to get stomped on as we move in about a week to 2 weeks out. Then we have one other model we like to look at, the CFS model. Again, 850 millibar winds, up 4,500 feet in the air, good representation of what's going down at the surface. Kelvin wave generation area between 120 east and 180 west right here. But this chart goes past history down here. You see little bits of westerly wind bursts, but they're mainly almost in the Indian Ocean or over Bali area. Then here's the forecast moving forward. We'll overlay the MJO. The solid contours are the active phase of the MJO. So here in late December, early January, the active phase was in effect. But what this suggests is over the next week or so, this dotted contour is the inactive phase of the MJO, but a very weak one. Easterly anomalies here, these blues are easterly anomalies. Not the Kelvin wave generation areas between these two tick marks, not really making much headway or taking much coverage over the Kelvin wave generation area. And if anything, notice these yellows here starting to track off to the east, suggesting the demise of La Nina. In fact, another way we could look at that, we'll do low pass filter. And interesting here. So here is sort of where, if you're in El Nino, you'd want to see this over the date line. Since we're in La Nina, you see the polar opposite. But it suggests that by sometime in March, La Nina starts fading out. And as it fades out here, you notice westerly winds, and we'll just take this off for a moment. You see westerly anomalies starting to develop over the Kelvin wave generation area, perhaps making things more favorable at the jet stream level for storm production. But of course, by March, you're also starting to move out of the prime winter swell window, so it's all kind of a moot point. Anyway, okay. MJO back over, we'll take off the low pass filter. So we get into, let's say the February time frame, maybe mid-February, weak active phase appearing, some sort of a mixed inactive period after that. It's hard to say. Still probably a very weak MJO signal. But the good news is, if you believe it, these easterly anomalies are supposed to finally start fading out, and with it, more than likely, La Nina. Next up, we start taking a look at ocean subsurface, depth in the ocean. West Pacific here, East Pacific here, going down 100, 200, 300 meters into the ocean. All these are the anchor lines for the TAO buoy arrays on the equator. That's all we're looking at, a couple degrees, 2 degrees north and south of the equator. Sensors, the X's are sensors on the anchor lines. And you can see warm water here, is confined to the West Pacific, and whatever warm water is in the East Pacific is very shallow. This is very typical of La Nina. And what you'd want to see if La Nina's dying at some point is this warmer water starting to make its way a little bit more off to the east. And we're actually seeing that this line here, the 28-degree isotherm, has been locked forever at like 180. It's starting to creep to 175, but it still has a ways to go to be what we consider normal. Now, here's the really interesting chart. We talked about this last week. We'll do it again this week. You look, if La Nina was in play, you'd expect to see cold water here, like we saw 3 and 4 degree below anomalies here. They're all gone. They disappeared last week. They haven't come back. Warm water that was sort of all holed up here is starting to ease its way over the date line. It's not really warm. We're talking 2 degrees above normal anomalies. But basically what we're seeing is a rather non-stratified, homogeneous water temperatures across the Pacific, suggesting the death of La Nina in the ocean. There's this other model here. It's basically saying the same thing, saying one little pocket of cooler than normal anomalies. What is that? Maybe 1 degree right here, and that's near south of Hawaii, and maybe a little pocket alongside Ecuador. But otherwise, neutral temperatures are in control. But notice, warm water still pretty much holed up here in the west, but it's trying to, look at a little stream. You could almost see a little stream trying to work its way in. Certainly not a Kelvin wave. A Kelvin wave would be a much more pronounced bout of warm water, and you need good westerly anomalies over here. And really what we need is more warm water to build up here, and that might take a couple of years. But certainly we're not seeing anything that clearly indicates La Nina. This chart's always a great chart, too, to see what's going on. Upper ocean heat anomalies, upper 300 meters of the ocean, East Pacific here, West Pacific here. Over time, here's our last Kelvin wave, warm water burst coming from the West Pacific to the East Pacific towards Ecuador back a year ago, February 2016. That was Kelvin wave number 6. And then we saw the beginning of La Nina, cool water at least, pushing east over the date line towards Ecuador, pretty much taking control from May, even April, into, well, we'll say November or so. But notice this. Here's your warm water. Notice continuing to build off to the east. By warm, we're talking not even a half degree above normal. But what it really says is La Nina appears to be dying. This is an extremely short-lived La Nina. We don't want to say that it is gone for fear that we'll jinx it. But at least for the moment in time, a more normal-looking water pattern is setting up across the Pacific. Sea level anomalies, another good way to see what's going on subsurface from the Jason 2 satellite. Mexico here, Central America, Peru, New Guinea here, the equator right here. You'd want to see negative anomalies right in here. Of course, if El Nino was in play, you'd see positive anomalies. So negative anomalies suggest strip out all the waves, strip out all the wind chops, strip out the tides. And if you have cold water or cooler water depth, it kind of contracts, makes a little divot in the ocean surface, a little depression. And that's what we see, -5 centimeters, but only over a very small area. And this is continuing to get smaller and less pronounced, really almost non-noticeable at this point, suggesting La Nina is dead. Of course, we don't see any positive anomalies suggesting El Nino's in play. We do see a little bit of normal anomalies, at least off of Peru. Next up, we start looking at sea surface temperatures, not down in the ocean, but surface. And if you ever want to see a striking change of what's happened in 2 weeks, this is it. This area had negative anomalies, negative temperature anomalies along here, working their way out. I mean, typical kind of weak La Nina scenario. And all of a sudden, we have much warmer than normal temperatures. What is that, like 2.5 degrees, 3 degrees above normal, building along in northern Chile, all of Peru, Ecuador, starting to work their way over the Galapagos, pushing their way out to at least 115 south, and really, there's no sign of any much, if any, cool water left out here, even to a point south of Hawaii. That's about where the last of the La Nina cool pool looks to be, but this very much warming here suggests trades have died. Now, remember, there's not warm water at depth, so it's not like a Kelvin wave erupting to the surface and that this warm water has come from the West Pacific or anything. But, it kind of looks like El Nino, but there's no way it is because there's no underpinnings in the under the ocean surface to support it. There was a cool pool that was starting to build off of Mexico, sort of like look like northeast winds causing an upwelling event in this area. That's all gone now too. So if nothing else, a return to normal in the East Pacific looks like it's happening. Here's the temperature trend for the past 7 days off of Peru, and as expected, warming pattern continues there. Same thing off of Ecuador, a little tiny pocket of, slightly cooler water, maybe a little downward trend. Galapagos, but, and here's one other little pocket right here of slightly cooling temperatures, but by and large, it looks like warming is taking root. There was this alternate cool, warm thing that's been going on since, in March, April, May. That's all gone now, too. It just very, very much looks like La Nina is losing its grip, certainly on the East Central Pacific. And then finally, the overview. You can see here is the La Nina cool pool, what's left of it. If this were a strong La Nina, it should be just raging, especially this time of year, January, should be just raging right off of Ecuador, Peru, extending out here south of Hawaii, but it never did. It always sort of was sitting right here. We've been saying it's a westward displaced La Nina, like a Modoki La Nina, which is always a sign of a weak La Nina to start with. Of course, we've always been wondering, well, if there was a super El Nino going on there, normally it seems like there's a equally an opposite reaction once it dies and you get a super La Nina. Well, we haven't had that. It's been kind of a weak La Nina. We'll see what happens, what transpires. 82, 83, there was a strong El Nino. It was not followed by a strong La Nina. And there was another El Nino that showed up about 4 years later in 86, I believe it was, 86, 87. And then the super La Nina showed up after that. So we'll see what happens. But for right now, we're not paying too bad of a price this winter. I mean, at least there has been surf, certainly plenty of precipitation and snow in the Sierra. So La Nina, not particularly strong. So La Nina is dying subsurface in the ocean. La Nina is certainly dead at the surface, or nearly so. But what effect is that having on the atmosphere above it? So we start looking at the Southern Oscillation Index. Difference in pressure in Darwin, Australia, and Tahiti. Negative numbers suggest the active phase of the MJO. That means more low pressure north of Tahiti. So we look for December and into January, we see a pretty good run of positive numbers suggesting the inactive phase of the MJO. Now we're starting to get into this bit of a negative run, certainly pretty strong here back over the weekend into today. Negative numbers, maybe suggesting the active phase of the MJO is trying to emerge. We look at the 30-day running average, another way to see what's going on. We see it was sort of in late December, it was neutral, starting going positive, which would suggest, again, the inactive phase of the MJO, and now is starting to dip at 0.10, so pretty much neutral, but again, suggesting, well, at least for past couple of weeks, maybe the active phase of the MJO has been in control. And then we look at the 90-day running average. We can use this just to look for the presence of La Nina or El Nino, and it's at minus 0.83, which is effectively at 0, which means neither El Nino or La Nina occurring in the atmosphere. Then our other atmospheric sign, getting a sense of what's going on with El Nino, La Nina, is the ESPI index. Like the Southern Oscillation Index, only it's measuring precipitation, actual precipitation anomalies north of Tahiti, really over a much larger area, equatorial Pacific, versus over a maritime continent. If the number is negative, like it is at minus 0.96, that suggests less precipitation than normal in this area, and you can actually see it in the graphic here, kind of dry air. This is the rainfall anomalies for the last 30 days, and most of the precipitation is over here. That's pretty typical La Nina. But remember, we looked at the ocean. both at depth and at the surface, and La Nina is effectively gone. Well, that only happened in about 2 weeks. The atmosphere does not change and does not respond that quickly. It takes months for the atmosphere to sort of really get a sense of what's going on in the ocean, and the ocean has to stay consistently, trending one way or the other. But if things continue like they are with neutral temperatures in this area, or even slightly warmer temperatures, at some point this number is going to start creeping up towards zero. We'll call this a lagging indicator rather than a leading indicator. We'll use the ocean temperature as a leading indicator, and we'll use the Southern Oscillation Index as a leading indicator as well. So for right now, this index says La Nina is still in play, and it clearly is, but that our guess is it's getting weaker. And then finally, sea surface temperatures for the Niño 3.4 region. This is the area used for monitoring El Niño, La Nina. Right now, January 2017, dead neutral temperatures. That's exactly what we're seeing in all our other data. The forecast, well, actually, you look back in time. Here was our El Niño back in a year ago or so, fading out this time. Then we had our La Nina, whatever of a La Nina it was, from April into about December. And now it's gone. And the forecast, this is what's very interesting. Temperatures rising to plus 0.4 degrees, almost a half a degree, and holding starting, about March or April or so. Half a degree anomalies is El Nino, bare minimum El Nino. But this is just under that line. And it's got to hold for 3 consecutive 3-month running periods. So, but the models suggest, well, certainly at least neutral, if not slightly warmer than normal. This would mean that maybe come the summer we might get a better southern hemi swell pattern than would be forecast, but probably later in the summer rather than early. La Nina is still in effect. It's probably going to stomp on the April, May, June time frame, but something after that, maybe the southern hemisphere will be a little more active. And certainly bodes well for next winter, a year out, but that is certainly a reach at this early date. And then finally, a quick look at California weather today. Oh, here, we'll roll this down so you can see it. Monday night, yes, light snow over the Sierra, this area. Rain, though mainly this is fading showers along the California coast. Low pressure dropping down along the coast by Tuesday morning, dissipating off of Point Conception. Dry pattern takes over. Notice maybe a little bit of a front trying to stall off California on Thursday. That might mean some south winds. Probably not a good sign. High pressure does not take control fully until Thursday night. And then California high and dry for the foreseeable future. Tahoe has been absolutely pounded. So we're on our third storm. Each one of these storms, this is just in January alone, each storm has brought in roughly 7 feet of snow. So we'll talk, let's say, 21 feet of snow from January, 1st or 2nd to the 22nd, 23rd. So that's over a 20-day period. That's a lot of precipitation, certainly in the Bay Area, down in Central California, even Southern California. If you're driving across the Delta in here, Sacramento Delta, it's all flooded, completely underwater, farmland underwater. This is actually a good thing. It will help replenish the aquifer, help set things up. The snowpack is nice and deep. You're driving along 80, and it's basically a solid 8 to 10 foot wall, both sides of the highway at elevation over the pass, and for a good distance down the hill from there. And anywhere in the Tahoe region, snow is consistently packed in the 6 to 8 foot range, depending on where you are at lake level. So a lot of snow in the region, and there's a lot of digging out still to be doing. Snowpack is certainly unstable, but the good news is we got a giant base. Probably needs a little bit of time to firm up, settle down, and then certainly we're going to get more storms come into February, March, April. Winter is not over, but we are well past normal precipitation and snowpack rates. That is great news for our drought situation in California. So to wrap things up, good-sized storm on the dateline. Seas not as high as quite expected. A little bit shattered in the San Francisco Bay Area, but still, nonetheless, solid swell on the way. Sideband energy for Hawaii, more direct for the U.S. West Coast. A bit of more weather for California. Certainly raw swell initially, then that'll fade out, and we'll get down into a more manageable swell height situation as we move later into the week. More swell, of course, expected on the charts, but more moderate in nature. Things settling down, the jet stream kind of dropping off, losing some of its energy as we expect the inactive phase of the MJO to start building in over the next week or two. So probably the next 2 to 3 weeks, things will back off a little bit. Then we'll see what happens. Too far out to know for sure. La Nina dying away quickly. It's all but dead in the ocean. That's a good sign. We're waiting for the atmosphere to respond in kind, but it's still, it's a big boat. It takes a while to change. When the whole atmosphere is used to moving in a certain way, it's going to take a couple of months for it to turn around. But just the same, things looking much better for next year. So that's it for this week. We'll do it again next week. Same time, same channel. It'll be on Sunday night next week. Thanks. Bye-bye.